predicting the direction of the reaction. Suppose we are taking an example of this reaction in which A moles of A combines with B moles of B, and it is giving us C moles of C and D moles of D. Now, if the reaction is at equilibrium, it is fine. But where the reaction is actually proceeding, whether it is moving towards the forward side or it is moving towards the backward side, how we can predict this? Generally, the idea comes in the mind that it can be the value of the equilibrium constant. Now, let us understand it cannot be the equilibrium constant. We cannot predict the direction of the reaction from the equilibrium constant. Then from where we can predict? First, let us understand where does our equilibrium constant comes. See, when we say it is an equilibrium constant, it means what? It's a constant. Its values has been taken when the reaction is already at equilibrium. Now, at equilibrium, whatever the concentration of C and D and A and B we have, when we put those values, we get a value which is called an equilibrium constant. And that value is fixed for a reaction. And if suppose under some experimental condition, we start doing the reaction, after 5 minutes or 10 minutes, where the reaction is, to which direction it is moving, how can we predict this? How can we know this? We can know this by a term called reaction quotient, symbol is Q. This reaction quotient expression is exactly the same expression what the equilibrium constant is having. That is why I have written it adjacent to this one. The expression of the reaction quotient is very similar to the expression of the equilibrium constant for that particular reaction. The only difference is whatever the values of C, D, A, B we put in this are the values at any time during the reaction. If suppose after 5 minutes only, we want to know where the direction is, where the direction of the reaction is, what we will do is we will find out the concentration of the C, D, A and B after 5 minutes in the reaction mixture. We'll put these values here, we'll get certain value. Now, if your Q is exactly equal to your K equilibrium constant, it means what? The reaction is at equilibrium. It means your system, your reaction is at the state of equilibrium, it has reached equilibrium. If this Q is greater than K equilibrium, it means what? That means the numerator value is much more than the denominator. That is why the Q value is more than this K equilibrium. It means what? If the reaction is having higher concentrations of C and D, that means the product, it means what? The reaction is now towards the product side. So the value of the Q is greater than the K equilibrium constant. The reaction is towards the product side, the C and D. And if this value of equilibrium constant is less than this Q is less than K equilibrium, Q cannot change. In fact, K cannot change. Only the value of the Q which changes. So if the value of the Q is lesser than K equilibrium, the reaction is towards the reactant side. So this is how we can easily predict the direction of the reaction, to which direction it is moving. The term used to give us an idea about the direction is the reaction quotient, whose expression is exactly similar to what the expression the equilibrium constant is having. And when we places the value, if the Q is equal to K equilibrium, the reaction is at equilibrium. If the value of the Q is greater than K equilibrium, the reaction is towards the product side. And if it is lesser, it is towards the reactant side. So it can easily be predicted to which direction the reaction is proceeding by using reaction quotient.